Anytime.
Now we're live.
All right, number 2. Given a 90%.
Oh my goodness, there's so many data files.
I know.
Okay, let me delete the old data files
Open up all the new.
so I don't get confused.
Oh.
Ooh, that didn't sound good.
Looks like a good chunk of them are, you get to select them, so. Nice in the family.
Okay, when everyone's ready.
I'm ready.
I am also ready.
Number two, I think, is not the second one. We are 90% confident that the true mean heart rate is between 4 and 5.
You can't have chance, so.
Yeah.
That's not all.
Got it.
All right, researchers determine the reaction time. Okay. Researchers said. Or the requirements for constructing a confidence interval satisfied. Why are they not? Isn't central limit theorem have to do with 30?
Yeah, I don't think it's the last one. I do, however, think it's the third one. But I could be wrong.
I don't think the first one's right. And I don't really think the second one's right, yeah, so I think it's
the third one.
Mm-hmm.
Yeah, I think we're going to go with that.
Of
the 4 types of confidence interval listed below, which one is appropriate for this experiment?
I hate scrolling back up.
It's the... I feel like I have this written down somewhere. But chances when you try and find it.
Well, because we don't know the mean yet. Well, I mean, if we did the...
Wait, was that lesson third? Let's see. 2 means pair. Let's see. 1 mean sigma known, 1 mean sigma unknown.
I want to say it's either the first or third one.
Yeah.
We don't know the mean, so it doesn't matter if we know the standard deviation. So,
is it independent or dependent? That's the thing.
Because they're testing the same thing, but it's male and female. Got my notes.
I think it's independent. Because they've sorted it into genders.
Yeah.
Okay.
So I think that would be independent. Because those 2 things aren't dependent on each other.
Yeah.
Oh.
Would be a 9. Which of the following can produce a confidence interval with a smaller margin of error than this 95%?
Wouldn't it be
if you're
The 30th customer, so
Then the other goes down. One, this can just confuse me.
I feel like less people would have less room for error, but I don't know if that's right or not.
Confidence level will lead to larger values of the Z score thing. The Z, like that. That's what it's talking about.
So which one?
Let's see. 1 second. 95% of the mean balance of a switch of the following will produce a confidence interval with a smaller margin of error. Increases, then the margin of error would increase and have a wider confidence interval. So if the Z error increases. I hate all the symbols because I don't know what they mean. I just know that it looks like a Z, so that's what I say, and then it just confuses it.
Well, it's either the first one or the last one, so it just depends on if less of a sample means less than the
But
market.
only 10 bank customers rather than 30 because 10 are likely to be more than 30.
I think it's.
If the Z increases, the margin.
I think the last one makes. No, I don't think it would be the last one. I think it's the first one.
I think so too, but I don't know if that's right.
Because you have a greater chance of 10 being more together than of 90 being more together.
Mm-hmm.
Like, your margin of error has to be bigger when it's 90 than when it's 10.
Yeah. That's
So it'd be
true.
10, right?
I think so.
So the first one. Let's roll with it.
Oh, okay. These are questions that I'm not too long.
Determine the margin of error for 90K. The margin of error is what we were confused by.
Yeah, margin of error is like super hard. I don't get it at all, really. I'm gonna be honest, but
when I
feel
went,
like we were
when I went to tutoring, and again, I don't know. She said that for margin of error, you can subtract the low bound from the or the low input from the high input, and then divide it by 2.
okay.
But I think there's a formula for
But I
it.
think this is the one that we learned very first, like in lesson 10, the margin of error. So it's just how we were doing it before. It's the
Lesson 10 is the one the tutor got me all screwed up on, so. Okay, here's the formula. Margin of error, lower bound.
it's you don't add the something into it. I can't remember.
Yeah, I know what I'm trying to remember too. I feel like I know what you're talking about.
I'm trying to see if I have it written down. I'm trying to do some.
I'm gonna go grab my notes real quick. Hold on.
Is it the? It's not the mean. It's like the Z thing.
Mm-hmm.
Standard of deviation over the square root of the.
Yeah.
Times the square root. I should really label all these. Standard. Okay, it's 2. The margin of error equals 2 times the standard deviation over the square root of n.
Okay, so n is 4, right? So the square root of 4 is 2.
Mm-hmm.
So the standard deviation, so you said 2 times?
The standard deviation.
Yeah.
So it'd be 2 times 1, which is 2. So it'd be 2.
would be times
2
2
times
times
1
0.01. Oh yeah. So
by the square root of n. But what's n?
N is 4.
yeah, because she.
She randomly selects 4 drive
Oh,
shafts.
okay. I was like, I do not see 4, but yeah, okay, I see it.
They like spelt
So
the
it'd be-
number.
It'd just be 1.
Yeah, so
I was
We
gonna
have to
draw one,
use the 95%. We
Mhm.
have to, so it has to be confidence interval times the standard deviation over the square root of n.
Yeah,
It
so
would give
isn't it
us
95? It's gonna be 1.645
1.96.
times the standard deviation.
0.96, isn't it?
I think isn't it 1.96?
Yeah,
So for
1.96.
Is that for 95?
Yeah.
Yeah.
Okay, because I have something else for that. So, so 1.9 times 2 divided by 4.
So 1.960 times 2 over the square root of 4, right?
Yeah.
Which is 2.
So it'd be 1.96.
Times 2 divided by 1 second. I'm doing it. See if I
Well, yeah, because if it
divided by the square root of 4.
yeah, it'd be 1.96 times 1.
6.
So 1.96.
I think so.
Would that be right?
I think so. Okay, the lower bound.
What? Oh, that's when we have to.
Do the
You know,
plus and the
yeah.
minus.
Mm-hmm.
Yeah, we have to plus and minus. Yeah. So 1.96 plus 1,000 and 1.96 minus.
Minus.
Plus 1,000.
No,
Yeah.
it's plus.
Isn't that right? The sample means 1,000 mm.
It would be plus 1,000. I thought it was.
I don't know.
I thought it was like z plus standard deviation divided by square root of sample.
Our
Yeah,
confidence
well,
interval.
that's what it is. But I mean, we already found the. Like it's just, it would be like 1,000 minus 1.960 times 2 over the square root of 4.
Do we use the sample
That
mean
part.
for that? Yeah, sample mean.
That's the only mean we have, so I would think.
I thought it was the same formula as before. You just added or subtracted, and you define the one with the mean.
What do you mean?
I'm just going over. Here we go.
So do you not like? So what equation do you think it is? I'm confused.
X minus z plus standard deviation divided by the square root of n.
Oh, you're saying plus that.
That's what I have down. But again, it could be wrong because this is all from that stupid tutoring session where I got all screwed up.
So I'm looking in the textbook and it's saying the confidence between two values is X. So is X just what we found, right?
X is the confidence interval.
Mm-hmm.
No. The sample mean.
X is the sample
X,
mean?
Yes, X with the line above it is the sample mean. And then
Okay.
the Z thing with the little star by it, or the confidence interval.
Okay, so what I'm seeing is X minus 2 times standard deviation over the square root of n. And then I see X plus 2
that's what
times standard deviation over the square root of n.
Mm-hmm.
So 1,000
minus.
1,000 minus
It would
be your lower one. To find your lower one.
1.960 times 1, right? Because the
Yeah.
2 over 2 is 1, so
So why are I confused? Why are you getting 1?
Because the standard
Oh, 2 divided by your square root of 4.
Yeah,
is 2, so yeah. 1.
but 1 divided by 2 is 2.
Oh, gotcha.
So it'd be x minus 2 and x plus 2. So 1,000. So it would be 1,000 minus 2 and 1,000 plus 2, basically.
Why is it minus
you
2?
have
Because
to-
isn't it minus
You have to
z?
use your confidence interval. That's why I'm
Yeah.
confused that you're not using your confidence interval.
Because the formula I have is x minus z times the standard deviation over the square root of the sample.
Yeah,
So-
that's what I used.
Isn't z
Okay.
going to be that 1.96?
Okay.
So you would do
You
your
would use-
1,000 minus 1.960 times 2 over the square root of 4.
Yeah.
That's what I did. But
So then wouldn't it still just be 1,000 minus 1.96 and 1,000 plus 1.96?
that's what I was trying to explain. But I think I
Yeah.
just didn't.
Yeah. And then
Because we already
multiply
did the
it by
margin. But what are you multiplying it by? That's what I'm confused by.
the standard deviation divided by the square root.
So what did you get for your answer?
Still trying to write it out. But the standard deviation is 2, and then the square root is 2. So,
But we're not. Okay, so the
So-
1.96, the reason we're just minusing and plussing that is because that was already the answer for that part of the equation.
Right.
Mhm.
I get it now. So for my lower bound, I got 998.04.
That's what I got.
And then for my upper bound, I got 1001.96.
That's what I got.
There you go. So you
All
got
right.
1001.
0.96.
I hope that's it, because otherwise I don't know how to do that.
Oh, jeez.
How large should n be? So now we have to figure out n, where n is unknown. So that's that weird formula.
To assess the accuracy of laboratory scale,
Oh.
standard weight that it's known as a
So for n, when you're trying to figure it out, it's z times the standard deviation divided by the sample mean, and then you
We
take
don't
that answer
have
and
the
square it.
What are we doing?
So I'm trying to get the part. So z would be
Number
the
9.
one. So z would be 1.960.
Oh, so we're trying to find the opposite thing.
We're trying to find n. So you do it times 0.01, and then I think the sample mean would that be 1 gram? The standard weight, I don't know.
Well, no, it says with an unknown mean. Like, we don't have a mean.
Fine. But we don't need the mean to find this
Well,
because we have
what
the
is
confidence interval 60 times the
I
standard
have the
deviation
formula for that.
divided by the margin of error.
Margin of error, that's what it is. It's not mean. Okay. I got it. Okay.
Sorry. The
No, I
margin of
just
error, which
wrote that
is
down wrong.
that 0.0001.
Yeah. So it'll be 1.960 times 0.01. You take that number and divide it by the 0.001, and then you square it. Well, that's fun. All right.
And I got a very large number.
1 sec.
Yeah.
I got 38416. Is that right?
That's what I got.
Wait,
Oh, whoa, what in the world is happening?
I got 196. But
You
then I
didn't
have to
square it.
square
But
yeah,
you have to square that.
that is a big number. Mm,
The mean area.
it's that big old number. Let me try it again just to make sure. Okay, so 1.960. I think it's because it's like these decimals or whatever. Jeez.
That one, it doesn't say to round the decimal, so for those it says round.
Equal. Divide it by. Yeah, I'm still getting that answer, so
So number 10. Are we on 10?
the mean area.
I think number 10 is the last one. But
You
The appropriate null
said
and
their fonts are smaller than
alternative.
advertising. Done right because it says smaller.
Well, null is equal, and then alternative. Um, yeah, so smaller.
That's what I'm thinking.
I always get those signs mixed up. So if it's
So-
pointing away, does that mean that it is smaller than that number?
yeah, less than.
Okay, so then yeah, I think it's the last one. Because the null is that it
The null
is that
level.
amount, but the alternative is it's smaller. So
Yeah.
And it's just test it. So we say that we reject the null when the level of significance A is
you reject
larger
the
than
null
A.
if it's less than.
If the P value is less than, or if the A is less than.
If
It's larger, then we reject.
Yeah.
if p-value is less than, you reject. If it's greater than, you fail to reject.
Yeah, that's right. Fail to reject. Yeah, that's right.
That should just be a second
So
one.
it's fail to reject.
Yeah, so we reject
Second
the
one.
null. Yeah. Group of statistics used to determine if something can they use in another way. Hypothesis. Oops, stop it. Okay, so stick. Oh, excuse me.
Size, random size, simplest 15.
I think it's no.
But I would say it's the second one.
Yeah,
Yeah, that's what I was gonna say.
Not enough.
We don't have enough data for that.
Oh boy, wrong question.
Wow, holy cow. My eyes stopped working.
Basically, it's just is it a type 1 or type 2 error? Which I don't remember off the top of my head. Alright. Type 1 error is the incorrect rejection of a true null. And type 2 is incorrectly keeping a false null.
So
It's rejecting a true null or keeping a false null, is what Google says. So she rejects the null hypothesis. In a future study, it is determined the new patient does not increase. So if she rejects the null and this treatment doesn't increase it at all, what is the null?
I think it's a type 2.
Yeah, because she's not a true. Okay, Jesus. Okay. If the level of significance is made very small, thereby making the probability of committing a type 2 error very small, what happens to the probability?
I think it's the first one.
or doesn't we increase the probability? Yeah, I would say that we increase the probability of a type 2 error, not reduce it.
Yeah, it would be a higher probability. So you guys are saying the first one?
Mm-hmm.
Okay, you can check. Look at some content. Okay. So you conclude that you should since
Don't we have to
if
know the
it's
p-value?
higher than the level of significance, would it be fail to reject?
Well, isn't it the p score or the p
Yeah,
level or
I don't think we have enough information to know.
Yeah, because it's just saying one is.
So I would just say it was the second one. There's a 5% chance.
Yeah, I
Right?
agree with that.
Okay. Okay. Wouldn't it be?
Is it
I always get confused on these ones.
I think it's a paired sample t-test.
You would like to look at the mean number of hours worked for wages per week by male students, and you would like a sample.
Well, it's a t-test if you don't know the standard deviation, but because
Isn't it independent sample t-test?
well, I think it's dependent because they're both students, but there's like two different groups, so it'd be paired.
But they split them up into females and males.
Right,
So that would be independent.
Yeah, because we decided earlier that gender is not.
A
That
dependent.
confuses me. Dependent means that they're kind of related, and I always forget like how gender factors into that.
Yeah.
So, we'll try it.
So the second one?
Yeah. Educators. So this one would be dependent because they're brother and sister. I feel like.
Yeah.
And then we gotta figure out.
So it has to be the fourth one because it's saying you use the brother and sister, and so you have to use the same brother. You have to use the brother and sister to.
Yeah.
Yeah.
So wait, which one?
The fourth one.
Okay.
Because it says if you select a brother, you have to include the sister.
Yeah, that's true.
All right, we
You're
finally use one of these dang things. 95. Confidence.
I don't even think you like necessarily have to input it yet.
No. It's 95% confidence. The mean dissolve.
Are you making popcorn?
Yeah.
That makes me really happy.
Yep.
Okay.
Like prediction. It's not good.
Guys, I'm so done.
We're
I'm
almost
so
done.
Oh my Hannah Montana.
Okay, so these questions very confuse me. You guys,
Tuesdays are so long.
like the 4 types of confidence interval. I gotta make sure to study that. Because just based off the question, like I don't know the mean or the standard deviation. So is it?
Well, but you would
The
know
4
it if you
types
put
of
it
confidence.
in. You see what I'm saying?
Yeah. So I don't know if we need to put it in yet or not.
I would say the third one, because putting this in the Excel sheet is going to give us the mean and
The
it's
mean
going to
for-
give us the standard deviation.
Okay.
Okay,
So the third one?
please. I would do the third one. My computer's dying. Hang on a second. I gotta get my charger. Or you guys can keep going and just fill me in. I'm not that concerned.
That's another lovely margin of error question.
Oh,
Which of the
fun.
following is the 95% confidence interval for this analysis? Input your answers for the margin of error. Well, can't we just put this into the Excel and it'll just do it for us? It's for the dissolved organic.
Well,
Like I'm not doing this by hand if I don't have to.
but do we know which one are we doing? Oh, it was the 2 sample t-test?
Well, when you open the dissolved organic one, it only gives you one list of numbers.
Oh,
So wouldn't it just be a 1 sample t-test?
Yeah, that's right.
Okay, what did we do?
We
We're
figured
copying
out,
and pasting.
because it asks for like the mean and the confidence level.
We
So
didn't
which
want
one are
to
you
use our
putting it
heads.
in?
The 1
So-
sample t-test.
Okay, that's what I
So,
figured.
alright, so we know it's 95%. Do we know the null? This is where I
I don't know.
tripped up.
I don't think so.
So if we don't know the null, do we just put like 0 then?
Yeah.
Wait, which one are we doing? Is it the dissolved
Yeah.
Yeah.
The dissolved.
organic carbon? Okay.
Is it the type of test? Is it greater than, less than, or equal to?
See, this is what always trips me up.
Yeah, me too.
I gotta look at the question here. It says the soil sample record organic. The measurements are recorded. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. That doesn't
I would
help
say
me.
you're equal to. Not equal to. I mean.
I think equal to. Not equal to, yeah.
So for your mean.
Well,
Is
wait,
that what
what's
we're
the
trying to
margin
figure
of
out?
error?
Oh, we're looking for the margin of error. Yeah, that's right. Sorry.
Oh, no, you're good. I just was afraid we missed it. Or I missed it.
Wait, it doesn't give us the margin of error.
It gives you a standard error of the mean. Isn't that like the same thing?
No.
It's auto.
So do we have to figure it out?
Well, can't you just subtract 15 from 11? Isn't that what we were saying earlier?
I was told earlier that you can figure out the margin of error by taking the high interval minus the low interval divided by 2.
Yeah.
I would like to test that theory.
Because, I mean,
Me
it seems
too.
faster. So,
I got 2.0245.
That sounds plausible.
Yeah.
2.025. Yep.
2.025.
Yeah, so it would be around that.
Okay.
Oh, excuse me.
Input the lower bound.
What did you guys get for that one? Because mine's being weird.
11.168.
Wait, I got 15.217
Is that the upper bound?
for my lower bound.
Lower
No,
bound.
sorry. Never mind. I got 11.168.
So then the upper bound was 15.217.
217.
So we're almost there.
Then we need the Hummers one. Basically the same thing. Yeah.
Oh, goodness. What numbers
But
do
wait.
you use?
So first of all,
We want to know if there's a difference in mean listing prices between Hummers and Hummers for sale in New York.
So the price.
so group 1 would be LA and group 2 would be New York.
Wait, but where's the difference?
It's down.
Oh,
to,
I
like,
see. Okay,
yeah.
I got it.
So we're doing
So-
the price.
Yeah, but are we doing
Price.
sample?
So this one's the paired one, right?
The paired sample, or is it the 2 sample?
I put the paired sample because
Because you want to know the differences, so it'd be the paired.
yeah,
You're right.
between the prices.
You're right. You're right.
Trying to figure out though,
Copy.
is there another list?
So we did the
for this?
paired sample t-test.
Yes.
Okay.
I don't wait. Hold on though, because if a paired sample, wouldn't you have a price for like LA and then a price for New York? I'm not seeing two different prices.
Yeah, you do.
You have to
Scroll down.
and it has Los Angeles partway down, and then New York on the other. Like the other one we did. It's weird how they do it like that.
Oh my gosh.
I'm not seeing it, but I'm so tired that I don't.
If you scroll down, like under J, where it says
Mhm.
Los Angeles, the city, if you scroll down to like
Oh, gotcha. It's over to the gotcha. There's New York.
110, then that's
There we go. Oh, okay. Gotta freaking look out for it. It's so stupid. Yeah, it like shows right there. Okay. There we go.
But I also have more in Los Angeles or Los whatever than they do in Maryland.
I don't know.
You?
Wait, did you put Los Angeles as your first or second?
Los
My
Angeles
second.
is group 1,
Ah!
and then Hummers is group, and New York is group 2.
So I did it wrong. Is that what you're telling
Well, I don't know.
me?
Well, that's what it says in the question. Is that
So Los Angeles is group 2.
Los Angeles is
group
no. Los Angeles
1.
is group 1.
Yeah, that's what it says in the question. And New York is group 2.
Oh, that's what I had. Okay.
Okay. All right. Here we go. Of the 4 types of confident, which one is most appropriate for this situation?
Scroll.
I would say the second one.
Because
Because we're looking at the mean of differences, and there we need it.
Calculate the 95% interval for the true mean. Okay, so
Lower bound. I got negative 649.052.
Wait, negative.
649.
Negative. I didn't get a negative. Wait, where am I looking?
Lower bound.
I feel like I did this wrong because for my T, value. I have like hashtag DIV. I don't know what I did.
Wait, what? Sorry, I missed that.
She has a weird.
Yeah, what do you have for your T value? Because I don't have the right thing.
1.672.
That's what I have.
Let me redo this.
I think I did it right. LA and first one, New York in the second.
Let me recopy them and see if I get the same thing. So you have 100. Do you have 109 for your sample number for Los Angeles?
What?
Are you on the right test?
No.
What? Am I doing it wrong?
This one would be a paired sample t-test.
A paired. What am I doing? What is wrong with this stupid thing?
I don't know. My Excel's being really dumb right now.
Probably
Jump
tired
on.
of being used.
It just seems like if I touch something,
Okay, let
everything
me
shifts.
copy these again into my thing and see if I get the same thing. So for your N for Los Angeles, what do you have?
For N?
Yes. What did you say?
Sorry, mine froze. I'm waiting for it to.
You're in
Yeah.
variable 1, I have 108. Variable 2, I have 63. And the difference is I have 63.
Okay, I think I might have gotten it. Let me hurry and paste the 63. Yeah, so my T is 1.672 now.
Yeah.
And my lower, okay, wait, what are we looking for? The lower confidence interval?
Confidence intervals.
It's negative 649.052. Okay, got it. 0.652, is that right? Or 052, that was way off.
So what did you get for it?
I got negative 649.052.
Yeah, okay. Thought you were on upper bound. I was like, what?
And then upper, I got 7279.783.
Not working right now.
783. Oops.
Oh, Erica. I guess we are kind of close to being done.
Okay, sorry. Are you guys on 25?
Yes. Except
Okay.
my computer isn't going to let me insert them anymore in Excel because it's like freaking out that I'm like, anyway, it's tired. It's old. Bless its heart.
Okay,
So
so
I'm on
we're
25
putting this
now.
into.
We need exercise bone density. Alright, what type of test is this one? Because is this one an ANOVA test?
Yeah, I think it's a NOVA.
It's got like 3 different categories.
Yeah, that's what I was saying.
So
Let's
is it a
hope
NOVA?
Yeah.
Okay.
Ugh, why do I have so many things? I gotta delete.
My computer is running so slow because of everything on it.
I'm like, why do you have like 6 different things open right now?
Yeah, and plus the Google Hangout is like killing a lot of it.
Let's see. Yeah. At least it's only like 3 variables. Good. Good. Yep. Okay. Freaking what is this? Got it.
I've almost got them. Oh, I am so sick. I'm trying to copy and paste it and it like goes different. And I just can't even hear it.
I feel like that's most of what my test is going to be, is just copying and pasting stuff into different categories.
Okay, so I copied and pasted everything. And I have so many things up that I feel like I'm gonna get messed up.
I just need to copy over the third one.
The test statistic. What? How do you calculate the test statistic?
Freaking okay. Finally. Jeez. Okay. What is the correct hypothesis test for this? Why wouldn't it just be like ANOVA, since we think ANOVA?
Yeah, that's what I put in there.
Okay. 26. Calculate the test. Okay, that's what we're talking about. Test statistic. Usually that's just in it, so unless we did the wrong test, which I think we did.
Is there a different equation for that?
Isn't it the same as F?
F?
Where's all those degrees of freedom?
F is the ANOVA F distribution. Actually, it might be.
Okay.
I think it's the same as F.
7.978.
So what's your F?
7.978. Is that what you have?
Yeah. 7.978. Got it. Damn test.
And what's your p-value?
P-value.
0.002.
P-values. Yeah. 0.002. Which of the following best expresses the conclusion of the test? 0.002 is smaller than that. These are the questions we kept messing with last time. Right.
So if it's smaller, then that means that it's sufficient.
There's
Right?
insufficient.
I don't know, I guess. But
I hate
2 or
these
3? We're so close to being done that I don't really care at this point. So it's insufficient.
I really want to say it's the second one.
That's what I'm thinking.
Yeah.
Alright, one more question. Okay, so this one is a 2. Wouldn't it be a dependent samples test because it's the same airline, it's just 2 different days? Didn't we do this one for like homework?
I think.
I think it's dependent because it's the same flight, it's just different days. Okay, closed bone density.
And we know if it's. How do we know if it's independent, or like which test to do if it's independent?
It's dependent. So I think it's a paired samples test because you have the same flight, but then she looked at like 14 days in advance compared to 90 days in advance.
Paired
so they relate
sample
to
test
each other.
is not an option.
Is not? Well, no, I just meant for like question 29, it would just be dependent samples test.
Dependent, is that what you said?
Yes.
Mm-hmm.
Yeah.
And then when you go into the Excel, it would be a paired samples test.
Oh, gotcha. I get what you're saying.
So now I need to open all this stuff. Flight.
Are we
So it
doing?
wants you to do 40 and 90. Okay.
So 14 and then 90. Okay. Okay. We are.
I hate this.
Well, this
because
is
I
actually
hardly
really
remember.
interesting. Side note.
Oh, for flying.
Yeah. My husband and I fly a lot, so it's just interesting. Our families live
Alright,
far
so
away,
now-
so we fly.
Sorry, I'm just deleting every 100 of these because
I remember this one because there were like these random blank spots. Alright. Copy.
Every time I touch my computer, it like freezes. This is so awful.
Like, no more. No more.
It wants to go to bed as much as I want to go to bed.
Here we go.
okay, let's see.
Okay. This section.
So what did you get for your T-score?
Okay, so T-score, I got 0.508.
Oh, what? It's not what I got. Why?
I might have done mine
Um,
wrong, but hold on.
I got 1.685, but I'm gonna exit out of it and open the file again and see if it actually me.
I just need to, I hate it when there's
Yeah,
like gaps in it because it just throws off everything. Alright, so
I just
14.
copy and paste it just how it is, though. Like I leave the gaps,
Well, yeah, I do too. It's just,
but I still get 1.685. So I don't know.
I might have done it wrong because I think I misaligned it somehow. So hold on. Alright, so you got 1 point. What did you get? Because mine just froze, so I'm going to have to let it sit.
I got 1.685.
Okay.
For the test statistic?
Uh-huh.
Yeah.
And then what p-value did you get for that?
Well, do we know if it's not equal to? Is that what we're supposed to put? Because that will change it.
Yeah, it's not equal to.
Yeah, no, because it's two different.
Okay, so my p-value is 0.096.
0.096. Okay.
Okay.
Which of the following best expresses the conclusion of this test? Use level of significance of 10. Oh, excuse me.
So the 0.096, the p-value is less than the other significance.
Which is a, it's 0.10 and then it's 0.9. 0.09. Yeah. So I want to say there's,
So wouldn't it be sufficient instead of insufficient?
Yes.
I want to say it's the second one, but I'm not sure. No, I'm not sorry, not the second one, the third one.
I think it's
No,
the third
I'm
one.
sorry. Yeah. Oh,
Yeah.
Okay.
I would say the third one.
Okay, I'm
Let's just
submitting. And I'm going to be honest and say that I'm not too concerned about my grade right now. $66.
Which one did I miss? What the Heck.
Well, technically we only got 10 wrong. It's just there was only
Like 30 questions.
yeah.
So which 10 did we get wrong? Maybe we can switch a couple around real quick.
The last one.
We got the last one.
And 28 we got wrong. I'm actually pretty pleased with us. I'm not gonna lie. 24 we got wrong, and 23, and 22.
That must have been one of the Excel ones. I must have done it wrong.
Yeah. 18. 15. That's weird. I was pretty confident about 15. 13. 12. 5. 3.
3. Alright. I'm willing to try to switch ones that already have options, but like, I don't feel like my Excel's being really dumb, so let's go to 2 real
Yeah, I'll look and
quick.
see.
What is 3? Oh jeez. Okay. Calm down. 3. Okay, so 3 is a QQ plot one.
3 what?
3 was the one about the QQ plot.
Did
Yeah.
either of you submit?
No.
Okay.
I'm gonna try to switch a couple of them around to get a little bit better, but I'm not gonna. So for 3, are the requirements for constructing a confidence interval satisfied? We said yes. Was it no then?
No, the addition.
I have zero clue about these questions.
Yes, I'm here. I'm kind of looking for a guess. Because central limit
I
theorem
really
has
hope
to
you
do
guys
with
do not just hear my husband.
30. No. I'm gonna guess the first one, to be honest.
That's what I was thinking. That would be my other guess. Would be the first one.
5. So we thought going smaller, so maybe going bigger.
In the bounds of 90.
Oh wait, I think I wrote this down somewhere. A larger sample size means more narrow. So yeah.
So maybe the last one?
Yeah.
It was the
that one
opposite of what we
now.
thought.
Yeah. And then 12. Okay, so we thought we didn't have enough data for that. So if we still think it's no, it's the first one, and if it's yes, then we have to. I think it'd be the. I don't know. Because what are the ANOVA requirements for tests again? Like as the normal distribution and something else. I think they could use ANOVA because it says like the sample variances are nearly equal, and I think that was the other one. So I'm gonna say the third one. I'm just gonna guess the third one for 5 or for 12. 13. Maybe it was a type 1 error then, because I thought it was type 2, but I'm gonna guess type 1. It's probably one of these middle ones, but my brain hurts.
15.
15. I think it's still fail to reject. I'm just gonna guess fail to reject. So, 18.
18.
Would it be the first one?
Sure. Honestly, I don't have a guess for that one. 22. See, I don't get the 4 types of confidence interval questions. So.
Me too.
So this one was the cars, so maybe they're independent.
Oh, instead of
dependent.
Which in my mind it would be dependent, but maybe it's independent because it's like 2 different places. I don't know.
That would make sense.
I need to ask her for like official clarification because in my mind things are more related than they are. 23's numbers, I'm not even gonna look at that. Or 24.
And then
Because
you
it's
got
independent,
28.
28. So if we still think it's insufficient, then it's 3. Or I mean 2.
Wait, what did you guys put for that one?
The second one.
Okay. That's what I put.
But I'm going to put the third one because we don't have enough evidence to say that all three of them are the same.
Right.
Right?
Yeah. And then
The last one.
But they're wrong.
excuse me.
32.
So maybe try the second one.
Alright, I'm gonna submit it because we'll see if that did any better. Keep going, keep going. I got an 86 with that.
An 86.
So that means just 4, and I'm okay with that. I'm okay with an 86.
Okay,
Yeah.
can you help me resubmit
Yeah.
mine?
Yeah.
Thanks, I'm pulling it back up. It's going to take a hot second. My computer's struggle busing. All right.
Oh, okay.
Okay, number 2 is the second one. Number 3.
3, I got wrong, so if it's not.
Number 3, I got it wrong too. What? We chose the first one, and then what did we choose first?
And then I think we did the third one. It's either second or 4. Take your pick.
All right. Number 4.
The third one
5.
is the fourth one.
6.
1.96.
Sorry, 1.96.
96.
Okay. 7.
998.04.
7.
1001.96.
Actually, okay. 9.
38416.
10.
Is the fourth one.
The which one?
Fourth. Last one.
11.
Second one.
12.
Third one.
13.
First one.
14. The first one.
Yeah.
15.
Got wrong, and so we've picked 2 or 3, so it's either 1 or 4.
All right. 16.
The second one.
Independent. 17.
Fourth one. Last one.
18.
First one.
The first one. 19.
2.025.
20.
11.168.
21.
15.217.
22.
Third one.
23.
Got 23 and 24 wrong, and I don't have any new numbers, so you just
Okay,
want to put
well,
we had before.
yeah.
Okay. 23 we had negative 649.052.
Okay.
And 24 was 7279.783.
25,
ANOVA
26,
7.978.
27,
0.002.
28,
28 we got wrong and we picked the third one, and I think the first time we picked the first one, so it's either 2, 4, or 5.
29,
Is the last one.
30,
1.685.
31,
0.096.
9, 32.
The second one.
All right.
Did we ever figure out what we had to do for that project?
No, not yet. I forgot about that. We should probably pick something that we're gonna collect data on, I guess. If we can't think of anything, I guess we could always ask her for an idea and go from there.
Yeah.
The test this week, I'm kind of focused on that.
Yeah.
Sounds good.
All right.
I'm
So,
gonna shut this off and submit the thing.
okay. We'll just meet next week.
Okay. Bye, guys.
All right.